It's theoretical. Probability itself is theoretical. It is experimental. Now, what do I mean by this? If, for instance, I take a coin and I toss the coin, are you following me? And I toss the coin, what would happen is that I don't know what I'll get. I don't know if I'll be getting a head or a tail. Are you following what I'm saying? That's why we said that it is what? Experimental. Are you following? The outcome can either be a head or a tail if I should toss a coin. So that's why it is what? Experimental. So, and that's why most times we need to carry out any activity as an experiment, because we cannot really say what the outcome is. So because of that, experimental probability is sometimes referred to as relative frequency. Now, relative frequency is gotten from statistics. When we talk about the rates or the number of times a particular thing or a particular item or a particular process or a trial occurs, the number of times it occurs. Are you getting me? So because of that, we can say that relative frequency or our experimental probability is equals to number of successful trials. All over total number of trials. That is, of course, from English language, we understand what trials mean. Trial means attempt. So I'd like us to write this down. So let's take an example. Let's just take a little illustration. Example, a special fear dice with a set of numbers 1, 2, 3, 4, 5 is thrown 250 times. Full stop. Find the number of times, find the number of times you would expect to get a 4. You would expect to get a 4 and B, a prime number. A special fear dice with a set of numbers 1, 2, 3, 4, 5 is thrown 250 times. Find the number of times you expect to get a 4, and B, a prime number. Now let's take a look at this. This is a question on experimental. This is a question on experimental probability. Are you following me? So now if you look at it very well, okay, let me rub everything off. Now, look at this. So they said probability of obtaining a 4. Probability of obtaining 4. That would be, now normally they say it's a special dice. So because it's a special dice of only 5 faces, apparently. So it has 1, 2, 3, 4, 5. Are you following me? Now, of course, that would mean that the number of times you can get is what? You can get a 4 is number of successful outcome all over number of possible outcome. Isn't it? Like we know already. Number of successful outcome all over number of what? Possible outcome. You've been taught this already. If you do not remember, you can refer back to the previous videos. Now, the number of successful outcome. How many 4s do you have on that dice? You only have 1 4. So that will be 1 all over the possible number of outcome you can have, which is what? 5. Remember that the dice is a special dice. It's not the normal dice we know that has 5 faces. I mean, that has 6 faces. In this case, the dice has what? 4 faces. It has it has 5 faces. Are you following me? And you only have 4 written on only one side of it. So that's why the number of successful outcome is what? 1. All over what? The 5 faces you have, which is what? 1 over 5. And that is why we have this. Now, but remember that there's a keyword that they said it was thrown how many times? 250 times. So this is when it is only once. This is for 1 throw. So that means naturally for 250 throws, that will be what? That will be 250 multiplied by 1 throw. 1 throw, which is going to be what? 250 times 1 over 5. And this will give us what? 50. So that means that we could have what? 50. We can have what? 4 50 times. That's what it means. It means the possible number of times we get the 4 is what? Is 50 times. I hope it's clear. So I'll give us a moment to put that in. So now in this case, they said another example. Another example. So the question is this. Johnson threw a dice 200 times. 200. Yes.
Not the second one, a prime number.
1 is not a prime number. So the prime numbers here are 2, 3, and 5. So you now say probability of getting a prime number. That will be how many? We have 3 prime numbers there. So that will be 3 over 5. And this is for only 1 throw. So that means for 250 throws. 250 throws multiplied by what? 3 over 5. So that will be 150 times. So that means we have 150.
Everything is black. I cannot see at all.
What about now?
I cannot see.
So now Let's move on to the next question. So Johnson threw a dice 200 times. Johnson threw a dice 200 times. Johnson threw a dice 200 times and obtained the following frequency distribution. And obtain the following frequency distribution. So here we have a table to show the distribution. So here we have the score and we have the frequency. Now remember, from statistics, frequency means the number of times. Are you getting me? The number of times something occurs. The number of times it occurs. So now we have a score of 1. So that means when you threw the dice, for it to produce 1, it got 32 times. He threw the dice again. For him to get 2, he got that 34 times. He threw it again, getting 3, he got that 30 times. 4, he threw it again, he got that 33 times. 5, he got that 35 times. And 6, he got that 36 times. So what this simply means is that for him to get a value of 1 from his 200 throws that he had or that he made, he got 1 32 times. He got 2 34 times. He got 3 30 times. He got 4 33 times. He got 5 35 times. Let me write this well. 35 times. And he got 6 36 times. So this is the frequency distribution of what he got. So now the first question, they said find the relative frequency of throwing a 5. Find the relative frequency of throwing a 5. So that means B. Find the relative frequency of throwing a prime number. And the last question, find the probability, the relative frequency. Well, when we say relative frequency, when we say probability, I hope you know we are saying the same thing. Find the relative frequency of throwing a 3 or a 6. Of throwing a 3 or a 6. Of throwing a 3 or a 6. So this is the question. This is the question. So we have find the relative frequency of throwing a 5. Find the relative frequency of throwing a prime number. Find the relative frequency of throwing a 3 or a 6. Now, we want to solve this question. The first thing we have to do, okay, probably we should just, let me give you a minute to write the question down. Now, solution. Naturally, the first thing I will do is, I would add up all my frequencies. Although you've been told a number of times, they've told you it's 200 times. But just to be sure, are you getting me? The first thing is to add up all the frequencies, which will be what? 32 plus 34 plus 30 plus 33 plus 35 and plus 36. That will give us, by the time you add everything up, you are going to get 200. That tells you that, oh, that's the total number of times the experiment was performed. Now, Then I said find the relative frequency of train A5. That is the first question. Probability or relative frequency of train A5. Of course, for A5, this we have our for 5. 5 was thrown how many times? 35 times. So therefore, that would be what? 35 over 200. So of course, 5 here is what? 7. 5 here is what? 40. So that means the relative frequency or the probability of train A5 is 7 over 40. So we move on to the next one. They said probability of train a prime number. A prime number. Now, if I were to be the one, first of all, the first thing is to identify my prime numbers. What are my prime numbers? 2, 3, and 5. Those are my prime numbers.
5.
Now, under 2, I have what? I have 34. Under 3, I have what? I have 30. And under 5, I have what? 35. Are you following me? So what I will just do is this. That will be what? 34 plus 30 plus 35. All over what? 200. Isn't it? So that will give me what? So that will give me what? So my prime numbers are 2, 3, and 5. So this will be 34 plus 30 plus 35 divided by 200. Divided by 200. So what would that give me? If I had everything up, 34 plus 30 plus 35, what would that give to us? That will give us 99.
99.
So that would be 99 over 200. There's no way you can divide it, so you just leave it like that. So the next one, which is the last one, they said find the relative frequency of train A3 or A6. That one is not difficult. It's not. Because when we see or in any of our questions, probability of A3 or A4. Is it 3 or A6? Sorry. A3 or A6. Now, whenever we see or, we already know that or rule is the addition rule. Or rule is talking about the what? Addition rule. So what do we do here? So which is what? Mutually exclusive. So that means I have probability of a 3 plus the probability of a 6. Isn't it? So now what's my probability of getting a 3? That would be what? 30 over 200 plus my probability of getting a 6. That is 36 over 200. If I add both of them up, that would be what? 66 over 200. And if I divide it, that would be 33 divided by, okay, divided by 100. So that is my what? Answer. Do we have questions? Do we have comments?
No.
Questions, comments?
No.
So like I said, I want to take it slow with us and this probability. By tomorrow, we'll be doing the last part of it, which is combined probability. So meaning that by tomorrow,